on, Leia. There we go. There we go. Leia, we're gonna stream now, okay? So you need to move. You need to move. You need to go away. Hello. Waited here for you. Have alone tonight. I'll roll myself into. Sup, Dylan? How's it going? Finally home. Amazing. Can't wait to see your next stream. Woot! All right. Let's get started. Hiding all the time. No, we want to see the session time. That's good. And yeah, we have the buttons that we care about. Dope. Tomorrow morning. Nice. I'll try to make it there. So I started pushing down the SSL support straight into Riot, which means if you build on Riot, then you don't have to think about SSL, right? You open a socket, you can say, all right, I'm gonna wrap this socket, right, in an essentially in an SSL sort of pair of readers and writers, right? And then you'll be able to consume from that, which means, you know, easier networking things. Like if you want to build a client on any kind of TCP or maybe UDP in the future based protocol, right? Then you don't have to think about the SSL at all. You just open the sockets and focus on your layer, which is like how to handle the data itself, right? Which will be fun. Yeah, and what I wanted to do here was make a test. So to be able to make a test for the client, we will also need a server. What's up, Leia? She's right here. Nope, that's not the right thing to do. And I can't really do this with one hand, can I? There you go. It's been a learning experience, to be honest. So there's a couple of things that could be rewritten, but I can tell you that the interesting modules will be like libsocket for libnet, for example, right? Like this is all the networking code that we have, which is not that much, right? There is a little more inside of the low-level I/O module, but this is more concerned with how do we do syscalls, for example, without completely taking over a scheduler, because we don't want to be able to do like a read from files, right, from file system, for example, right, and have that entire core just block. Okay. There we go. Yeah, I hear you. Prepare to be disappointed though. It's like it's it's all a number. It's like I was weirded out by that. Like we have an FD module here, right? And this thing has modes and other nice things, but the underlying file descriptor from the Unix module, right? This is an abstract type, and if you object magic into a number, right? Then it gives you a number like 0, 1, 2, 3, 4, right? Because this is how you actually refer to file descriptors in a Unix program, which I didn't know. Yeah. So we built some niceties to work around file descriptors and stuff like that. But the low level APIs are like, yeah, weird. Not what you expect. They're not. They're old. They're really old APIs, right? Okay, so this is our network test. We have a little client, a little server, and we would like to do a similar thing. Mwah. This cat, just gorgeous cat. But instead of connecting directly through the socket, we would like to use the TLS module to create a config and wrap the socket, right? So our little SSL module here um, is providing this function called of socket, right? Where if you give it an authentication configuration and the current host that you're trying to connect to or have connected to, right? Then it will give you back a reader and a writer, right? Like a stream socket reader and a stream socket writer. But that little T in the middle is actually the T from this module, right? So that you will know in the type, oh, this reader actually, is SSL enabled. I am actually super happy with how these reader and writer APIs ended up. They take a little bit of work sometimes, right? And sometimes we need to introduce these abstract types, like locally abstract ones. But at the end of the day, you can do these pipelines of transformations of data, and you can register in the type what exactly is going on, right? So in this case, a Unix, right, socket, just a socket, becomes a reader of a socket, right, which eventually becomes one of these things. And if I do the type there, right, a reader of a TLS of a socket. So it just keeps adding layers to that, which is kind of nice. Okay, so test. How do we do this? Gonna start with the same network test as we had before. We need to do the listening and all that stuff just the same. Let's add the test stanza as well. So this will be our SSL test. Cool. So net test here will become SSL test. Cool. The main difference is that instead of calling receive on the buffer directly, we are going to call SSL, right, of socket, and we're going to give it the connection. And I'm realizing now, as I say this, that this is a bad API because there is a way of initializing the socket, right, for clients and another one for servers. So maybe we want to do of client socket, right, here, and then we'll do a similar one of server socket. They have different flows, right? So here what we did make, this will be make client, and then we will have a make server, which I expect it to be similar to. Cool. So in this server side, we'll do of client socket of server socket. Sorry, and then we will get our reader and writer, right? And I think we actually get an okay. We're gonna need to add this in the API. I'm not sure exactly what are the parameters for the server socket, but we will definitely have these two, right? Hey, you are. I know, right? It's a good song. Okay, Leia. Yes. Reeve Taylor Hawkins, indeed. Look at that. Look at that beautiful, beautiful cat. Okay, so I think the reasonable thing here to do as well, um, since we were porting code, right, from OCaml TLS, the TLS EIO, let's say adapter, right, for TLS. I think it makes sense to grab some of that code as well, right, and adapt it to work with Riot. Um, yeah, so let's do that. Let me just move things around because the cat has taken over the desk. Can I code, Leia? Is that okay with you? Yes? Okay. Cool. So let's open that over there. And they used a raw module for describing these things. They have a sink and a source, and I think we implemented what would be the sink, which is the client flow. Maybe not. Right? And we want to implement now the server flow. And the server flow is much simpler, right? So we're gonna do that right now. And it looks like if this is all we need to do, then we should be good because we already have a drain handshake function in place. So we do make client, right? We'll do a make server. And the server does not need a host, but it just needs a config. And if it takes a flow on EIO, that means for us it will take a reader and a writer. So we'll make a state that will be active, and we'll just initialize the engine. Right, server config. And we don't have a flow again, but we have a reader and a writer, so we'll push those into our struct. We don't have any lingering C structs, so that'll be no. And our receive buffer is going to be its own C struct. And we'll do the same size as we did before, 4096, right? And then we'll just call drain handshake on that. So cool. Make server does not have a host here anymore, right? So we don't need a host there. And I think we do need a config. So I think we will call that config, since that is the name it should have, right? It is not just auth, it is actually config. All right, cool. So Let's go to the interface here. We don't have a host. We do have a config. Right. So now, when we do of server socket, right, we need to pass in a config. Now the big question is, will the config be the same, right, for the test, for the client and the server? I don't know. So we can have a look at that. So when people are calling server flow in the examples, right, I think we have a TLS-CIO. Here's a client, right? And the config is defined. Okay, that's the config. And in the server, we actually have a different configuration, right? With a private set of PEM and key files. Ooh. So as I said before in other streams around this, TLS not my forte. I'm really relying on Camel TLS here, right? To learn what the hell's happening. So we're gonna put this thing here. We'll do config, and that's gonna be a separate config, right? Than the one we'll use for the client side. So we are expecting to have, I don't really know what the minimum config would be right here, but I like that we have a config, right, server module that has a server function. Because we might, whoa, this is all optional? No, okay, sorry, it doesn't end there. Cool. All right, so we can try the default config and see where that takes us. Hey, Samuka Dev, tudo bem? An e-medio. So I wonder if there is a default config. Because if there is a default config, then we can maybe just use that, right? So we can make our config here be in both cases. I think the client doesn't have that. We'll see that in a second. So if this is the default, right, then we can just say, all right, TLS config server. If you don't have a config, that's okay. That is completely a-okay. And I'm thinking just to make this a little more readable, we'll do that. I don't know what you think, but I think that looks kind of nice. Boring, straight code, one line after the other. Oh, thanks for the follow, Emilio. Samuka Dev, thanks for the follow as well. Folks, I'm kind of sad today. One of the things that happened today was that the headphones, the cable started to chop off. It's been 10 years since I've been using these headphones, and only now it's starting to fail, which sucks, because hopefully I'll be able to fix it, but if I can't, I don't know. I don't want to think about that. Okay, so we have our server, we have a reader and writer, and that means we're just going to do an IO, right? Read here. And in this case, we need a reader.read. And we pass in a source, right? Which will be a reader. And then we pass a buffer. And if you look at the type of this thing, that is a reader. But we're missing one error here, which is end of file. I think that maybe should not happen, but we'll deal with those errors later. And we have a writer, which means instead of doing socket send, right, we will just do IO write all, right? And write all takes a writer of any kind and some data. So here we'll do writer. And I think this is also complaining that we may have a problem, right, with end of file. Yes. So again, some of these errors they might never happen, right? Like when you're writing, you're never going to get an end of file. Oh, nice. Thanks so much, Dylan. I really appreciate that. The nice thing about this Bayer Dynamics is that most of the parts are replaceable, right? So I'm counting on being able to get a new cable, right, and just solder it or replace it myself. But we'll see. We'll see how that goes. So okay, if we have this, that means now we should be reading and writing right through the reader and writer that goes through the socket. And if we try to run the test, okay, maybe that will fail. Why are you failing? You're failing in Riot.ml line 604. Server, what don't you like? Oh, sorry, this is server config. Cool, that makes sense. Our test fails because we don't have a server certificate provided, which I think is okay. So I wonder, dummy server certificate, or maybe even yeah, there we go. Cool. So we're gonna go into our test folder and we'll do just that, right? I think we have a fixtures folder that we can use. We do private PAM. And country names, SE. We don't really have a good one here. No email address. Okay, so we have a. Do we need a public PAM? I think maybe we don't need it. We'll see. Keep it there for a second. Going back to running the test. And in our test tune file, we'll say that this depends, right? Just like that. It depends on private PAM. Cool. So we can close that, this, and the other thing. And now we can pass in a config. TLS config server. And we can look at how they've written that configuration here, right? So we want to set the certificates. Okay, so we need private of PAMs. Do we need both of these things? Hey, Fortran999, thanks for the follow. We can do certificates. We want to do we want to do multiple? Default config, own certificates, own cert, non-single cert chain, multiple cert chain. So we want to do single. And then we can just do one certificate chain. So they are doing something here to get up the private PIMs that, convert these files into a certificate clearly. So we can have a look at that. And I think we have the URL right here, one. And the call is private of PEMS. Okay, so this is not doing much. We're reading the file. We can do that. In fact, we probably want to do that differently with a file reader, right? And we do have a function to X5 and 9, which we would definitely need to add as a dependency for tests. Doom project. We test x509. Pum info or show x509. 065. Cool. And we can add to a dependency to that test. Test Doom SSL x509. I do wonder if it makes sense to just always include the library, since you kind of need it for doing TLS on both sides. Ooh, look at that. We have a command here from Jaguar. We do need to double check if it's going to call RMRF, RimRef somewhere. It looks safe, folks. It looks safe. Let's go and do that. Fixtures. Whoa. Look at that. It created things. All right. Perfect. And this is TLS PEM and fixtures TLS key. I think it's not PEM, is cert, right? I wonder, do we have a PEM? No, we had a PEM and a key here. Do you think it's going to work? So we're going to do let cert. It's going to be file, open read, right? Fixtures, TLS cert. And I actually think we can do pipe straight into reader and then do IO read or reader read, right? Which has stat interface. So we can just put a buffer here. IO, but I think maybe even has a default buffer. No, we don't. It would be great. And I think what I really want is a read all. But we'll do it with a buffer now. IO buffer with capacity, and we'll just do 4096. I don't know how big that thing is, but whatever. And this could be okay or could blow up. So we are going to do this. I'm gonna put you there. I think we already have a star somewhere. No, we don't. Okay. So we're gonna do result, get okay, right? And this will be the length, which we don't care about. And we'll just return buffer to string buff. So that's gonna be our CRT, right? Or at least the contents. And now we want to do the actual parsing. So x509, we're going to call certificate, decode PEM, right? And do you know if this is a single one? Or multiple? Do you use it on the server side or the client side? Cool. Okay, so this should be our certificate here, CRT. And then we have our private key, right? And same deal. But instead of a certificate, we're gonna go for private key here. And other than that, it should be the same, I believe. And when we create the thing, it's gonna be certificate and private key. So that that looks good to me. Let's see what the compiler says. Certificates was on cert and a cert chain. Okay, so we just need to say that this is going to be a list. Cool. All right, small thing. We want the ports to be randomized, or we will need a better way of doing this. Right now, some of the tests use the same port, right? So if you run them together, they crash, which makes sense. And we'll do OCaml run param b1 param backtrace. There you go, that one. So we can go to our test, line 34. This is not this is not happy with the way we decode. So we'll do logger debug font. To string buff. Let's see what we get. Oh, sorry. Want to do info. So that is our certificate. Looks okay to me, but maybe we're missing something. We can try decode multiple. I think the main reason will be that it just returns a list. But it definitely is okay, now it's failing with the private key. Decode derived? Oh, wait. I am being a dummy. This should be key. I'm just reading the wrong thing. Perfect. So now we have some errors somewhere else. So info, that will be, we don't need that anymore. Cool. So now SSL line 172, this is failing. Unexpected exception TLS failure. We get bad payload. And I think this is the client breaking because we're not actually creating an SSL wrap socket for the client yet. But we can do that. Come here of client socket, right? And we don't want a configuration right now. No, the opposite. We do want a config, but we don't have a host. Okay, and the config that we used, I think if we do Doom project, then here we can actually use Castor. (002). I implemented the change Jawar that we discussed on the forum. We didn't discuss it. I wrote about it. I would love to discuss with you about it, though. If you have any thoughts, more than welcome. How do we do that? Or maybe we did discuss. I forget. Did you reply? No, not yet. Okay. But yeah, this thing. So do Castor. And we just need time. And I have So for Blink, it's actually the default. If you go into Blink, where is it? SSL. I have a branch that is using this new Riot SSL stuff. And here, if I do, how do I do not split? How do we do this? Unified. There you go. Apply and reload. Cool. So transport. Right now, when you make a connection, we use this by default. So we build that thing by default using Castor, right? Here. I think the tricky bit, or the bit that needs some work, is being able to say, oh, actually use this other auth module instead. Like if you have custom certificate or something like that. Whoa, all my cables are broken. And I think what I wanted to show, or not even show, just grab. What the hell are we doing here? Right. In our decoding test, so I have that tiny little function, but that's not the function I want. Okay, so let's go back to Blink. We're going to borrow that function from here. There you go. Doing format, run again. So instead of doing a receive over there, we'll just do an IO reader read, right? And I'm passing the reader. In the file. And we need to do our writer in the sending. So where is the sending? Oh, the sending is happening way up there. Cool. So then as soon as we connect, we'll just do the wrapping, right, in the TLS socket. And then when we need to send, we'll just do IO write all send writer. And if we get an EOF here, we'll just stop the sending. Of course, we also need the Mirage initialization. That's something else that I don't know if it makes sense for Riot to do by default. I don't think most people want to care about this stuff, right? They just want it to work off the bat and be okay. I wonder if you can initialize it multiple times, though. If you can, then that's great. If you cannot, then bit of a problem. All right, so now we can probably go into the Dune file here. Just show me the Dune file. Code, Blink, Dune. We want this to, right? TLS failures. You wanted it to be here. So SSL line 241, right? Really? Here. 172. Oh, okay. So when we create the thing, make server, right? This goes into the receive loop and does drain handshake on the TLS server. And this is the same flow that we use for reading for the client. Before we lose our minds, I'm actually going to consider setting the domain, right? Because in Blink, when we do a connection over SSL, currently, we actually get the host out of a URI. And then actually pass that into the client socket, right? And that seemed to solve so many problems. And we're going to do that. Host is URI available. Oh, we just have the address. Okay. So that's a little easier, I think, of domain. Actually, maybe the domain name already exists for localhost, right? Root. Maybe not. Of string exception. That sounds good to me. And we'll do 0000, right? And then we'll just get the domain from that and pass it in. Invalid hostname. Okay, so maybe localhost. Nope, it did not like that. Let's look at the command that we got from Jawar. Does that command have? Oh, lethal TTV. Empty line on the end of the CRT can mess with them. Good point. We don't have an empty line at the end. No, okay, Leia, you're in the middle. Off you go. And the command said, the command is not, it's saying, okay, localhost, CN is localhost. Okay. So does that mean I should be able to connect passing the host, localhost here? You know what? We are getting now this SSL failure, and it seems to be happening on both sides. So both the client and like process 4 and process 3 dies, right? So I'm gonna guess that this is not just right on the code and maybe the certificate and the way that we're reading the certificate is maybe wrong. So this is blowing up with an exception. So let's do a little try here. Or actually, we can probably do a try all the way here. So try, right? And if we get that exception, which it should be SSL, we need to expose it. God damn it. Exceptions, TLS units. We get a TLS failure. And I'm going to put those straight in the MLI. There you go. Failure, and we have a failure here, right? Tonight. Server error. Hopefully it has a printer, since this is a TLS engine, right? TLS engine. Put the print failure. It has. Perfect. So we'll do that, and we'll just end the process in a happy note. Invalid message. That's the error we get there, right? And we can do the same thing for the client. Invalid certificate chain. What? So, this is a client. I'm gonna find out. So when we build a server, I guess the server is the one that's saying that? Or is it a client? Signature algorithms, renag, I don't know what old, like, clearly there's a lot of domain knowledge here, right? Required to use this thing. Could it be that the authenticator is the problem? Because I can also pass the null authenticator, right? Which we define right there. And maybe that's what we need. Oops. So what am I doing here? Oh yeah. Yeah, that was that. I guess we don't even need this. That's kind of nice. We do need the certificate. Do we need? Yeah, we need the certificates, but we do not need X509, right? No, we need it. We need that. What we don't need is Castor, which is good. One dependency less on this test. Let's do something bad and go into the IO layer, runtime net, IO, and we have here some debug logs. This is from the runtime. We cannot really enable that. Never mind. Let's go into the socket layer, libnet, I said. There you go. Here we have some traces for the amount of bytes that we're sending, right? We're gonna do just quickly here, instead of sending the bytes, let's actually show the data we send and see that it's not plain text, right? Because we definitely don't want to see a plain text hello world. So logs here should be trace. So we should see sending this much, and then whatever we send should not be that. Yeah, sending, that looks about right. That looks pretty TLS-y, pretty SSL-y to me. Don't know about you, but yep, it's pretty nice. So we'll go back to info. We will disable that. Not gonna lie, one of the main reasons I had to do this, to push this down to the Riot level, is that I almost leaked Twitch tokens, like auth credentials. So yeah, having them encrypted, a must, especially if I'm going to be building stuff with credentials, right? I want to be able to just go from info to trace and just make sure that if I accidentally print something that I shouldn't, it's encrypted, it's fine. Wait, no, it wouldn't be fine in this case, right? Because you know what the keys are, right? Anyways, we built it anyways. It's here. So we have the server and the yeah. So let me show you what we did for Chatty. For Chatty, right? We need to send clear text for the into socket for the IRC protocol. So we have this command to string function that we use to serialize something, right, into essentially whatever can be sent into the buffer, right? However, we also have a print command. And this thing specifically says the password has been redacted. But boy, you have to be careful, right? Because print command prints the thing, and if this was returning a string, it would be exactly the same signature, right, as command to string. Yeah. So my guess is that we'll have to do this sort of thing at the protocol level in a lot of places. Anyways, so if that's that, then does that mean we can now build, for example, client pools, TCP pools over like SSL? Because if that's true, then that means we can start building things like Postgres clients, right? Ooh, we can actually try this again and see if it still works. You do. I would love you to do that. Do it. Please, it would be amazing. Hello, chat. I'm writing from our TCP IRC, Riot, or Camel, Twitch client, all the keywords. And I think if I do a pool, and if we do the last version of Chatty, we actually have a hide cursor. Doom project, Minty2. What are you talking about? You should be there. Oh, we didn't merge it. Oh, sorry. Yeah, opam install. Minty. There you go. 1, 2, 3. What am I doing? No, no, no. It's not Bulma CSS. It's just Bulma from Dragon Ball Z. Well, that was fast. Took us under an hour to get the thing running for client and server. You're gonna see there? Okay. 1 second. I stand on the shoulders of giants. All the crap I'm doing is tiny, I think, compared to the things that other people have built already. Like, we would not be able to do any of this SSL magic, right? If it wasn't for OCaml TLS, for example. I actually didn't stream earlier today because I was feeling absolutely terrible. Because in one of the streams where we did this, I forgot to actually add the right copyright, right, to a bit. Exactly. And Hannes opened an issue, rightfully so, saying, hey, license the copyright, right? And it was like, oh, he noticed that some of the code was actually copied over from the EIO, right? No, LWT. My response immediately was like, this is clearly an oversight, right? Like, I'm really sorry about that. I fixed it. I pointed to the video where we did it, right? And then I updated the release so that the only release of Blink that we will push out, right, the first one already would have the right copyright there. Yeah. But I was feeling terrible because, like, how could I forget about this, right? Like, everything else that we've been doing has the right, has at least some indication, right, of a provenance if it's not something that is entirely original that we're building, right? Like, even here, it's like, this is inspired by Elixir's Mint, right? Bubble Tea does the same thing with Bubble Tea, right? Inspired by Bubble Tea. Even inside of Riot, right? When we implemented the vectorized I/O inside of the runtime network, I/O, yeah, I know, but rejective sensitive dysphoria is a shit thing to do, to have. Yeah, so originally I think this was the thing that we had. First tab. On the first tab, we already had that. Code taken from EIO and so on. But now I made sure that everything has the right copyrights and everything. So it's not something I was thinking in the heat of the moment, right? But yeah. Ooh, dirt. Hey, total oversight. Look, we use the same word. Yeah. Oversight. Does it happen to anyone else that when you go into discuss, then you have to actually refresh, like hard refresh, before you can use the website? Because sometimes I go in here and I look, I'm trying to click around and do things, select text, nothing happens. But if I do a Command-Shift-R, right, and I get a hard refresh, then the website works. Anyways, so I was feeling bad about myself, so I didn't stream earlier, I was just like, okay, how can I do this right? How can I fix the layer so that all of the copyrights that we need to put right are gonna be in this one place? Uh, and we ended up with this PR, the SSL socket is the one that we're working on, where the license includes all of the things that we're deriving from right now, which is not much. Some key pieces though. Hey Felipe, thank you. All right, so we have that. We can commit and say feed SSL for client and socket servers. So if we have that installed, that means we can try some other things, right? Like it would be easier to build an SSL transport in Atacama now. Like right now, the transport does this. No, no, it's this is just a MacBook Pro. But I've been naming my Macs something ending in Osh for a while now. I think the first one was called Muffintosh, and then at some point I started naming them after Star Trek ships, and this is for the Cerritos. And I have Mac Studio at home that is Titan Tosh because of the Titan. Um, so on. Cool. So now we can do SSL here, right? Thank you, thank you. And this should be a little bit more work, but it shouldn't be that hard to send and handle handshakes and stuff like that. I believe. But I don't know. Honestly, I think maybe this API, this interface, we want to rework because it's a little big right now. And there's things like the controlling process, right? That I don't know if we're gonna need them at all. Yep. So then if you do TLS in Atacama, it's like start, a pool of this many sockets listening on that thing. So this is more for like receiving multiple connections and handling TLS on them, right? Let's see. So listen, right? We will get some listening options. And I think listening and connect are going to be the same. If I look at Blink, Blink is doing this a little differently, right? In Blink, we have a transport. And the transport is just a tiny interface right now for connecting. So it doesn't do much more. But we also have a connection module, right? That represents a connection after you've connected it. And if you look at this, this is a little GAT where we hide the reader and writer type because we don't really care. The interface for writer and reader actually ignores the thing that you're writing from or to, which is kind of nice for us because we can pack in here a TLS reader or a clear socket reader, right? And internally, it's just saying, okay, this is going to be the protocol I'm going to use. So when you call Blink request, for example, then we just unpack that protocol, right? Because we already have a connection. And then we just turn that request into a buffer and use the writer, right, to write the thing. Like, this is so straightforward. Like, it's embarrassingly little code happening here, right? Same for the streaming the data out. But this connection type makes it possible to have this very clear common interface between the two transports, right? TCP and SSL. In Atacama, though, we don't really have that. We're returning now a raw socket, right? And our connection is actually a process. And this receives a socket. So maybe we just want to use the same pattern. That sounds about right to me. Transport connection ML, right? We will want a module like that. Because a socket. Oh, no, wait. We already have that. I think we already have it. It is not yet a GAT, but, yeah, exactly. Yeah, this is the same pattern, right? Like you have a type and you pack in the transport here, and then based on the right transport, we just call the right function. So I think here, instead of receiving a socket, no, wait, I think I spoke too early. All right, let's start from the beginning. Atacama ML, right? When you do, can you hear me? I sometimes can't hear myself, so. Just holler at me if you cannot hear me. When you start a link, we need to pass in the transport module. By default, this is going to be TCP, right? And then we create a pool. And the pool is just another module. Or rather, we're creating the specification of a child, right? So then we can say, all right, this process, the top level one, is just going to monitor the pool. And it will allow up to 10 restarts of the entire pool. Cool. Thanks, Jawar, for the feedback. So if we go into the acceptor pool, right? The pool begins with some state and defines a supervisor module, right? Where we do kind of the same thing. Yeah, we have a start link function. The pool in itself is a supervisor, right? That will receive an acceptor count, how many acceptor processes to have, right? And it will create one child specification for each. So then this way we say like we have Atacama is one process. And then we have a pool, which is one process, right? And this is monitoring. Pipe, right? And then this thing is going to monitor n processes, which will be acceptors, right? So you get a little supervision tree here. This is terrible for drawing, but you get what I'm trying to do. Cool, right? The number is not static, is actually configurable. So in the bench, I think, yeah, we set the acceptor count to 100. This could be 1, right? When you start the pool, you need to say how many acceptors you'll have. However, right? So we will call the this child spec, right, to start this process, and this will be from here up. These 3 little functions, right? These 2 functions really are the acceptor. We have a state which has a socket we will accept. As soon as we have a connection, we call handle connection, and this actually will create this socket and start a connection process. So every one of this, right, will actually be linked to several connections. So every connection is its own process. which is kind of nice because a crash in one connection for whatever reason, right, cannot impact the rest of the supervision tree directly. And inside here, right, we run your code. So it is worth noting that right now, right, the acceptors themselves are not supervisors. So if a connection dies, then that's kind of it, right? If they were supervisors, then when a connection dies, then it will try to start it again. But we haven't done that work yet. No, one acceptor, this is just accepting connections in a socket. Once it receives a connection from a socket, right, it creates a new process to handle that connection. So one acceptor is like an unbound number of connectors right now. Connections right now, sorry. Cool. So I'm doing the important work here, aligning these things. Okay. And at that point, we do connection ML. And so this is really the thing that will handle the connection. When we initialize it, we call the socket handshake, right? And this will depend on the protocol. So if we open our socket module, it has a transport inside, right? So we can call T handshake on the SSL side or on the receive side and so on. So my guess is that in the transport for SSL, right, when we do handshake, here is where we will want to actually initialize, right, the SSL of client. Because up to this point, right, we should just have a raw socket. There's no much more. So the question is, how do we pass your configuration down here, right? We'll need to figure that out. But we have a socket, and not only do we want to do the handshake, right? This thing that does the drain handshake, but we would also want to, I guess, save the new reader and writer somewhere, right? So it's starting to look like me that this type that we get in, like, say, handshake and stuff, oh my god, handshake returns a unit. There's nothing there. So that type is probably wrong, and we want to have a type, right, for the actual connection, so that once we go through the handshake, right, we end up in the same type, but that type is fits both transports. Kind of like we do in Blink, right? Where we have this connection type that it fits both protocols. It fits both transports because they are encoded here, right, in the writer and reader. So maybe this is all we need, a writer and reader, and that will be fine. So instead of calling T receive, right, we'll see. Okay, so we definitely want to do the SSL of client here in the handshake level, because after we do the handshake, right, we call the connection handler, which is like a callback to say, like, all right, connection established. You can do something there if you want. But then we just go into the loop, and the loop is this function, right? And the loop is just receiving, handling data, right? And then continuing to loop. mute for a second here. Okay. So how do we do that? We start we do init. Do we want the socket already to include, instead of a stream socket, a reader and a writer, so we can override them? Or do we want a handshake to actually go from a socket, right, to some type that will represent, right, the connected thing? See you are. Thanks for hanging with us. Yeah, my guess is that we'll need something like the connection type here. We don't really need a protocol though. Maybe, but not right now. We don't have a URI. We do have a socket, so we can probably save that. So then when we do the handshake with the socket, we end up with a connection, a con. And then we can actually pass around the connection everywhere. Let's explore that for a second. So handle that a con, and we have a con there, con, connection here, closing the socket. So init receives a socket, that's fine, right? But then after that, we get a connection, and then we just initialize connection, and we will just do connection everywhere. And the good thing is that now that we have a connection, we have a reader and a writer, right? Ooh, Jesus, Leia, what did you eat? So that means we can do our good old reader read, right? And then we'll do connection.reader. And then we just need to pass in the buffer. And I believe the buffer has been unspecified so far, handling data. Right, before, when we did socket receive, no, the buffer is inside there, isn't it? Yeah, it's inside the socket where we have the transport. It could be that we just need to put the thing here. This two, the reader and writer. So we leave the connection as a process as it was, right? But that would mean when you do acceptor pool, we create the socket. So at this stage, we would already know you do make socket, you gave us a transport. The problem is that we don't actually, oh, we do have a socket here. Does that fail? Yes, it does fail, doesn't it? Acceptor pool, we create the connection and we just pass it in there. Let's see, error transport ML line 69. Okay, let's get you compiling first. Good. Acceptor pool. Handle connection. So we're creating a buffer already, knowing the buffer size. And we're going to socket make. And make connection. We need a pair of this. We don't actually need the socket anymore. We probably shouldn't save it anyways. Oh my god, what the hell were we doing here? Object magic, no. Go away. I think maybe we could save the socket for pretty printing purposes. So net socket pretty print, and then we'll do t.socket. Like that. Cool. So do we want to do the handshake immediately when we try to create a socket? If we do, then we don't want to do that here because we are still, right, inside of the acceptor pool process, like an individual acceptor. And we do not want to take down, is this phones that are sounding weird? No, I'm good. and we don't want to take the acceptor down if we fail to connect the socket. So let's move that into I think the easiest thing will be to move this into the init function, right? And here's where handshake and make become the same, really. So now in the acceptor pool, we have received a connection, which is a streaming socket, right? We have a buffer, but we will not create it. We will send in, right, the buffer size. And we can create the buffer in here. And I think we shouldn't need the signature. This should be fine. Okay, we don't have the transport. So connection is going to be socket. We can probably just call that connection. Buffer size, handler, context, and we also want to set in the transport, state transport. Cool. So first things first, we're gonna try to make a socket, right, with our connection, and we'll get a connection out of that. And then we can call handshake, but here we will already receive that connection. So it's not gonna take a raw socket anymore. Cool, connection. Sorry, no, we can't do that. We will have to do make, and make will have to set up the socket entirely. And then we'll just get a connection. And I don't like the distinction between the two names. I think socket should be called connection. Whoa, CM Griffin. Hello, Raiders. How's it going? How you doing? We're riding some camel over here. We have a little Paul here, Leia. Welcome, Raiders, indeed. Thanks for the follow, CM Griffin. You may find some familiar faces. Hello, Alex. I'm having some issues with my cable here. There's like half of the audio does not come through, which is really sad. It's an old pair of headsets. Yeah, so Hi, my name is Leandro. You can find me on Twitter here, show you who I am. I am building a bunch of stuff for the OCaml ecosystem lately. Here's some of the libraries I've been working on. Um, Riot, scheduler for writing like Erlang or Elixir style code in OCaml, right? And a bunch of libraries on top of that. The ones that we're working on right now, it's called Atacama, which is a socket pool, which allows you to build servers that use like all of your cores for free, right? And yeah, we're trying to support SSL into Atacama now. In the first hour of the stream, we got it working for Riot, so we were able to do a little like SSL TCP server, right? And now that I think of it, we actually have something running. We have Chatty from the last stream, right? I think maybe it broke down after a while, which is a TCP IRC chat that we wrote in the last stream for Twitch. So if you say something, it will pop up here, I believe. There you go. CM Griffin says something. It needs work though, but it's a start. The goal here is to make the OCaml ecosystem as fun and productive to build stuff in as the Go ecosystem or the Elixir ecosystem or the Rust ecosystem, right? There is a lot of stuff to be built. But yeah, that's what we're doing here. Also, we love functional programming, but we're not like into type puzzles, right? So we normally go for the least amount of the most amount of type safety that will not get in the way of building things, right? Of the developer experience, of the ergonomics. Hey, live stream series, don't worry, it's fine. We all start somewhere, right? We do a lot of learning here in the stream as well. And this week we've been doing a lot of really long streams. Since I wasn't able to go back home for Christmas, then I was just here, stuck in Sweden. So we've been doing like, I don't know, 12 hours on average a day of streams. It's been pretty intense, but we built a lot of things and it's been a lot of fun. Any is fine internally. Typing it, no, 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 no. I think you took it too far, man. Uh, I think there is definitely a level of type safety, right? That is baseline. You know, like I want to know what type everything has, but maybe I don't want to play a lot of type puzzles with, like, for example, monads, right? Maybe I just want to be able to say, hey, print this string, and it just does the thing and returns nothing, and that's fine, right? So a lot of the code that we're writing here is like that. We use types, right? We use them where it makes sense. Sometimes we use pretty advanced types, right? Or type level things, but only if it's absolutely justified. If it's going to enable, right, a type safety that we need, or if it's going to enable a better developer experience, we go for it. If it does not, right, if it puts a lot of burden on the reader or on the user of the code, then we don't use it. We stay away from it. Yeah. So with that said, I'm gonna go back. Oh, this is Leia, actually, the cat here. That sounds like what I said, just with more words. Yeah, I think just the any triggered me. Anyways, if you have any music requests, just drop a Spotify link on the chat, and I'll get to it. Without further ado, so where were we? The comma. We know how to show it. I don't know the lyrics. Okay, so the idea here was in the acceptor pool, right? We'll just pass in all the data we need for it to create a connection on its own. But we don't really care about that, right? So when we spawn the process, we call the init function. And here we try to create the first no worries, no worries. Lurk away. So here we will actually create the socket, and we expect that to handle all of the preparation it needs because we need a connection back, right? And a connection now will also include the handshake. So we would expect the making to be maybe a little messy here. We might not need this handshake at all. So make, we want to do transport, right? Transport's going to be transport interface, right? We want to extract that, and we want to call transport handshake on the socket, right? Like we have here. And if everything is okay, then we should receive a reader and a writer, right? And we'll stuff those straight here into the... I think I'm going to do this in 2 steps because we also want to save that, right? Like that. We're going to stuff the reader and the writer here. Unused variable buffer, that should be okay. We want to create a buffer. So if everything goes well, then we can do, all right, let buffer. Wait, are we creating the buffer here? Or is the buffer being created for us? I think we can even do that, because the buffer is going to be internal to the socket. Buffer size. Because that way we avoid allocating, right, until the very last minute. When we know that we have a handshaken socket, so we know how to read and write to it, then we can say, all right, we will create a new buffer, and that's going to be our connection, and we'll return a connection back. And we don't have handshake anymore. Format, all right, the problem here is that this should be a socket. Actually, we probably want to call it con, like the connection we have on Blink as well. We can format again and run the code. There you go, perfect. So let's define that let operator, result bind, boom, build again. Why don't you like it? Just let me edit my code. If you don't like, okay, there we go. That makes sense. So transport handshake, now we need to modify that interface. Handshake, you get a socket, but the thing that you're going to return back is actually going to be, what is it going to be? We need a source IO reader T, and we will need also a destination IO writer T. Perfect. And that means our handshake here, right, we'll just say net socket, right, to reader and writer. And then we can do an OK on that. And I think that should be fine. Line 38, what don't you like? Okay. It is this one, right? The left one. that is intermittent right now, and it just makes me very irritated that it just like goes in and out and in and out and in and out. It's small things. So now that we have there, we can probably go to Atacama MLI, and then we will have a handshake function defined in our transport here. We can update that. So what's the problem? Transport 38, it doesn't like that. What do you mean doesn't like it? We're returning the right tuple. Reader and writer. And if we open Blink here, transport ML, right? We can go all the way down to the connection and we'll have something very similar. We will do SSL, right, of server socket. And we need to pass a config, which we don't have yet, but the socket we have. And this already returns the tuple we want, so we could do OK on that. Hey, the Kingy, thanks for the follow. What's the problem? Okay, so you definitely don't like that. So what if we invert this, right? Instead of receiving the socket, right, you receive a writer and a reader. And I believe this is how we did this in Blink as well. Yeah. And I don't know if we will continue to need a transport, but let's say you pass in transport, right? No, you won't be able to do that because you are the transport. But we have the buffer size. So in this case, transport, right? Just like before, I should just keep that open. Connection ML, right? Blink, one up, blink, and then transport. Right? You get a socket, you return a connection. And then, how do we do this here? Right, so here we probably want to pass in the transport. We have the socket. And in the connection, we just do transport, right? We already have connected. Close. Handshake. Right, I think this makes sense to me. So when we initialize the connection, we will initialize that through the transport, right? So transport, handshake. like here. So every transport has a chance to define how they're going to grab that socket, right? And turn it into something. Okay, Leia, please. I love you, but you can't fart like that all the time. It is distracting. For my own sanity, I'm gonna rename this module to be connection, and I need to rename this one then. We'll rename this to connector, which means we can go to the acceptor pool, and when we say connection, we say connector, right? Close that. Cool. So now the connector will use a transport to get a connection back. Oh, so much better. Like, so much better. Like, things are starting to make sense right now. All right. So let's go to transport. So the first thing we want is a handshake. I don't think we need listen and connect and all these things. I think most of them will be handled by the underlying socket layer, right? But in the handshake, we do want to create a connection. So we'll do reader and writer, right? And that's what we create there. What did I do? And we want to call connection, make, right? Reader, writer, for sure. We want those things. This also will take a buffer. And I wonder if we need to, I think it's okay to just pass in the buffer size that we get up here. So we are sort of passing along the buffer size, right? These LSP errors are being very annoying. Okay. And this is clear sockets, so that should be all. And that way, we have created a connection. We don't have to do handshake. We don't need a buffer anymore, right? We also don't have a transport anymore. We'll see how that impacts us. And we don't have a socket, so we can just return that connection. It's probably doesn't even need like that, right? Oh, sorry, we need to create a buffer here, since we only have the buffer size up to now. But that doesn't fail, so that should be pretty good. And we don't have these things, which means we don't have a PP function as well for pretty printing, which is completely fine, right? We don't care about that. And because we have a reader and a writer, then we don't need a transport here anymore. We can just do IO reader, right? And then we read into that. We don't have a socket here anymore, which is great. Reader, we read into the buffer. And this would be con here. Interesting. We had a timeout before that we're not going to be able to use as nicely anymore. And this function still returns perfect, a buffer, right, out of the half of, or whatever much we read from into the buffer. So we just want to do here writer, right? And we'll do IO writer, or write all actually, write all into the writer, and we'll pass in our data. And I think the API should be the same. Int, yeah, that sounds good. And close. Okay, so we might need a function for closing a socket. We will see. This is the wrong stuff now. I don't think I need that anymore. Handshake, perfect. So where else are we actively using the transport? I don't think we are. Hey, Owen Codes. Thanks for the follow. Yeah, correct. We do not need that. Because we know now that it's going to be a reader. Then why do we even have this stuff? Is a connection really just the reader-writer pair? And everywhere where it says socket, this is really a connection. Thank you. Except the one place where it should say socket. And I think we also are missing our pretty primitive function. We don't have that anymore. We probably don't want to do that anymore. Cool, that sounds good. Transport, handshake, whatever transport we have, we'll go through that. The handshake does not take a transport anymore because we already know who we are, right? We will remove the closing here. We'll just pass in a buffer size and a socket, and we will make those mandatory. So when you do handshake, we need a socket and you need a buffer size, right? And this is going to be an integer. But you do not return net, you return a connection T. Perfect. And we do that. Okay, cool. Hey, gentle automaton, thanks for the follow. And then we do transport. It's going to be a transport interface. So I think I'm going to remove almost everything here because we don't need most of the stuff. We're not really listening through the protocol or the socket. Like if we go to the acceptor pool, right? Here we just call network accept, right? And we do our own listening. And that's fine because this is a socket pool. So we should know something about what we are listening on and so on. So the transport module is just passed in as a transport here. Like the only reason we have that threaded all the way, right, is to say, hey, handshake the socket. Afterwards, we will have a reader and a writer pair, but it will be all hidden inside of a connection, which is kind of nice. So we don't have a closing anymore. She's okay. We'll do that. And we don't need to listen. We don't need connect, accept, close, receive, send. I think we just need a handshake, which is kind of amazing. 1 second, the cat is doing something. I don't know what. Leia, o que tá fazendo você? Ah, tá falando? Now, behave. All right, result bind. Cool. Net socket. This is not even that. There we go. There we go. That's the stuff. Now it's starting to make more sense. And I think this can fail. No, this cannot fail. Reader, writer. So we'll do let connection, make reader, writer, buffer size. Format, build. What don't you like? Line 6. You don't like this? The interface? What are you saying? Expected declaration, socket, net socket string, buffer size, int, connection. What are we missing here? Unix. We have that. This has all this stuff. Oh, Leia. Now. Ay, making a mess. What are you doing? You're misbehaving? You want attention? You can sit here. Okay, I'll just keep coding, you do your thing, all right? What I don't get is why these returns make should not return a result. It should be this. Cool. Connection, double N. So we can go into the socket module, which should go away. And when it does, then now we get a handler, perfect. Line 13, everywhere you say socket, we're gonna go with connection. Except where we say net socket. Cool. And then in line 7, what? Oh, this is the connector. Line 7, when we do an error, error receiving data. Close EOF, and we're missing EOF. I need to get rid of that EOF at some point. It is not very, yeah, it doesn't really matter. For this, then that. Cool. Line 16. What is the problem? Closing connection. 。  . 。  . 。 . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . So I'm thinking that we will want to pass in, right, some initialization for the transport itself, right? So that will help us say, all right, we'll start a transport. So the transport can have some state, like the connection number, for example, right? I'm going to postpone that for a second here just to get everything up and running. So Atacama ML, line 15. No, where? Echo ML. What? We're still using big strings? Example echo. Haha. IO buffer. That is the new big string. Perfect. So if you go into Atacama MLI, right? We don't have a socket, we have a connection, and it just has no. What? Wait. The transport doesn't have any of this stuff anymore, right? But we have two transports now, TCP and SSL, and we don't really have a socket anymore, right? We have a connection. And I don't think the connection has these things. Send, receive, handshake. I guess it does. Maybe not a handshake, but. And then we just replace this by connection. Cool. So test, echo test, socket's going to be connection, right? And then our client here is pretty dummy, but it's just a test, so it's fine. Bench echo, and this is the benchmark we've been using, right? To understand how slow is Atacama really. And of course, if we go into Atacama ML, we'll see we don't have a connection yet. So now we do. Oh no, what do we do? Atacama MLI, line 6, receive connection. T, timeout. We don't have a timeout anymore. What else? Oh, we are missing a variant here. And I think the problem is that we should be using IO result. I don't even think we need a receive here. We just need a send in the connection. $92. And handshake will now return a connection. And here we might need EOF. And what else we need? Oh, socket. And then buffer size, right? Second variant does not allow AOF in line 92. What are you talking about? I did this and it worked. We're going to copy that type right there. Woo! All right. So that builds. It does not mean it works, right? But we can probably try to call TCP Kali on that socket and see if it even does the thing. Exec bench echo ML, right? And we'll do a release build here. Cool. Looks like we are ramping up connections. Actually, we should do the same as we did in the benchmark, which is just 100. Just 100 connections. Pretty good throughput. Let's see what we had before. Okay, much less than before. I wonder what did we do that changed that. I guess we're going through the reader and writer now. So if I stash all the changes, right, and we run this again, then I think this was doing a lot more throughput before. We'll see. 50 Mbps more, less. Whatever. It's fine. It's good enough right now. The important thing that we want to test is not really that, but whether we can do SSL. And I think the best way of doing that will be actually to layer HTTP on top and see if we can make a call to HTTPS, right? Which we won't be able to do because we don't have the TLS config yet. That sucks. Let's see what else changed. So now we start a connector process immediately. That's fine. A lot less code. We're going through the IO read and IO buff and IO write, right? For writing things. We can also try telnetting, right? And I don't think the port matters much right now, but if we do hello world, so that's still, it is working, right? Which means whatever we did is not that terrible. Feet, what do we do? So we essentially rebuild this to work with the IO read and write streams. Please, okay, thank God. Are you afraid of the dark? So now that we have that, and because we already have released 004, right, we could do upon pin Atacama 005, right? and try to run the next layer, which is Nomad, which is the HTTP server, and tune exec. Cool. So this means if we try to build, it will fail. We go Nomad.ml, we say socket, we want to say connection. Hello world has the same problem. Hello world ML, right? Socket, connection. And if we run this, invalid HTTP version parsed. Okay, so maybe we're doing something wrong here. Oh. Hey, LiveSmith series, thanks for the follow. Oh, we had the TCP echo server running, and that's why this got stuck. Jesus. All right, let's run it again. Pretty terrible. Can't assign requested address. I think that was a problem with ulimit last time I checked. Whoa. What the hell is this? And something is just doing bad things. Okay. Oh, funny, Aconcagua. What is killing my process? Jesus, something is running real hard. Okay. Not too shabby for a homegrown framework or network stack. Could do better, for sure. We're having some issues with sockets. The number of descriptors. And I think the problem here is that Atacama is doing a stupid thing. And the stupid thing is that when a connector, right, finishes, we are not really closing that socket. So the dumb thing we can do is just to do that and then do net socket, right, close. Because we have the socket here. It's just called connection there, right? So whatever happens inside of all this, eventually will close with this. And that probably is the reason we had a fun and then protected finally, right? So even if that function throws, then we want to be able to say protect that, right? And I I forget if it was this way. Yeah, that tracks because then we're not exhausting the amount of connections, right? 397. We are so back. Yeah, I like this. Okay, cool. So we're gonna do a commit fix. Don't forget to close the connections. We're gonna push that, right? And we're just gonna do an opam install at the comma y, so that will restart our server. And eventually that will restart, and when it does, then we will run Hoja to run another benchmark. We're not really testing the speed here. We're just saying like, all right, what happens if you throw 10,000 requests at it? Does it fail, right? Does it blow up or something like that? Oh, okay. I guess it didn't need to rebuild. Woo! Look at that. That's better, right? Considerably better. Like the last time we run this thing, it was like, well, we have some 1.5 seconds. We have 3,000 connections that couldn't be served. Even the ones that were good, because we managed to do this in time, were like 0.1 or like 130 milliseconds to run. And now everything is consistently under, right, 100 milliseconds. And we have one here of like 554 milliseconds, right? So 99% of the requests are under 40 milliseconds. I would say we're getting started. It's okay. I want to see what the errors are on these things, right? So this is doing something funky. And my guess is that since we've been running the runtime for a couple of requests, like 30,000 now, there is some lingering state or something that's getting in the way that we should probably be cleaning up. Yeah, look at that. So there's a few 70 operations that timed out. And those are not processes that died. But it might be processes that have unexpected values, right? So let's do that. We're gonna grab the hello world example, right? And we're gonna run it with debug logs. We're gonna see a ton of logs happening here, which is completely fine. This will be much slower, right? But at least if something fails or if we're logging some errors, then we'll be able to see them here. That is a ton of logs. I don't really know why these particular operations are getting stuck there. It could be a problem deeper into the runtime, like the way that we're scheduling the syscalls, right? This is gonna take ages. I wonder if at this volume, the scheduler, the I/O scheduler, should be using a different data structure for handling the amount of processes we have. Because right now we have this very naive atomic list, right? I think so. So let's do a test there. 'Cause my gut tells me that we are handling now a non-trivial number, right, of file descriptors, right? So when you want to add something or remove something, right, then sometimes there will be these atomic loops, right, that constantly try to add something or remove it from the collection. And really, what we want is something more like the proc table, right, where we have a log and we have a hash table under the hood. I don't know how this is gonna work, but we're gonna give it a shot. So that's our new type, right? It's pretty much the same. Can't really unbox it, but that's fine. We'll create a table here. And we already passing the size as a default, just fine. I think for now we can ignore that and just use something large. So, okay, time to implement, right? We want to use something like protect, right? And we'll do fun. And in here we want to do hash table entries. We don't have entries, right? To sec. I think we have to sec. We have to list. No. Which makes sense because this could be really, really big. T table. I hope no one's calling this. And we're gonna do list of sequence, right? And that's what you're gonna get because that's what we had before. And we're missing our T log, our log there. I think that was the type we had. Entries, yeah, that is about it. Works. Cool. So find, it's an A and a B, and we return an option. I'm gonna open the interface here to write, so we can see what we need to return, right? So this is an association option that we're looking for. We have a key, right? Where the hell is find? Are we even using this? Or we're only using it for hash key? Oh my god! This is so terrible! Why did I do this? Oh. Of course, it's never gonna work for like a realistic number of sockets. Jesus, how does Atacama even do that well? I guess it's because we have only 100 connections, but then in the Nomad OHA test, right, we are using thousands or maybe closing and reopening them. Hello, Michi. So we're not using that, that's fine. Hasskey, however, becomes very easy to implement. Right? We do hash table, actually mutex, protect, right? and with the tlock, and then here is hash table, and we do member. That's it. Giving myself some breathing room. And find is actually going to be hash table again. Mutex protect, right? We want to do that for everything. And we'll do find opt, which is t.table. And then, oh wait, find by actually has a function. Find, do we have anything? Filter map in place. I love that function. That is not what we want, but I love that. Iterate, no. Okay, so find by is a terrible function, and I guarantee you right now, this thing is a bottleneck. So we'll do a sequence, and then we'll do sequence filter, right? And that will be our function. So that should keep the things that pass that, right? And then we'll do sequence, and I think we can do, we need a function to take one element. I don't see anything that returns an option here other than the finds. Oh, this is literally what we want, right? Find. And then find all by. I think will be very similar to this thing, but there might be a different find function here. Find. No, this will be filter. So we want to filter everything that passes that. And then iterate. Iter is gonna just do the same. So we'll do protect, right? Hash table iter. And then we get the function first. But I think the function here in iter, right, takes a tuple. And here we have a key value, right? So we'll just do key value like that. And now comes the trickier ones. Is entry, is empty. I think we can do hash table size length, right? So mutex, protect, tlock. Cool. Now insert. Oof. We want to. Why do we have insert and replace? Right. Add takes a table and a key and a value, right? And returns a boolean, whether the key was already there or not. And in this case, we don't care. And then replace actually calls replace, which definitely doesn't care. And we have this function called remove by, which is essentially filtering, and then we find the keys that we want to get rid of, right? So it's a lot like that. And this would be like to remove, right? So we can probably do filter and then sequence map, right? And then we will get, if I'm not mistaken, right, we will get the key and the value, and we want to get the key out, right? And this will be we could probably do that in a single stream. And then we do sig ether, and then we will get a key here, and then we want to do hash table remove, right? T table, and then passing the key. Okay, this might not be the best rewrite of that data structure, but it might just work. Rack, we don't need recursiveness anywhere here. Line 26, what are you complaining about? I am literally giving you what you want. I give you a predicate, right? Remove by AB bool unit. Cool. So line 1, it says it's not compatible. What are you saying? It's empty. Right, we need to do 0. Almost there. So line 7, maybe line 8 now. No, still line 7. Find all by. Right, and we do list of sequence. Line 8 of the interface and 18 here. So hash key member T table. Right, so that built. Let's see if the tests are still passing. I expect most of them to do that, but oh, my bad. I still have the Nomad server up and running. So if I go back here, did I close it? Yeah. Atacama also closed. Okay, that's more like it, right? All testing to be passing, perfect. I wish I had a benchmark now for this, but we'll do this. Fix, move away from atomic list in dash map. And yes, I called it dash map because I like dash map in Rust. I know it's not even close to the implementation of dash map. But if the interface is safe, then I can remove the implementation, right? Change it, and eventually make it more like that. So this is more like wishful abstracting, right? So let's rebuild this thing, right? And see what happens. I'm actually gonna go for a little less logs and debug. Go. Okay, we got to 16,000 sockets before we started failing. And now we're just fumbling around. Notice how the number is kind of the same. I wonder if we need to partition, right? The number of sockets that we have. So instead of keeping all of them in a single chunk and doing a single poll for all of them, we would do polls. No, I think we cannot. Yeah, if we have an instant timeout, we could do polls in batches, right? Like poll 1,000, timeout if there's nothing, right? Poll the next 1,000, and so on and so forth. I don't know if that is the problem though. Ooh, but this is gonna be terrible results. Like absolutely horrible. Jesus. Come on, almost there. 2,000 responses more. You can do this. 250 more. Hello, user 5711234. Definitely not a bot like name. I believe you are human. I believe you. Because you believe it. Thanks for the follow. Wow, this thing just like said no. We have 8 connections left, which I think is the 8 processes that died here. Maybe not 8, but 4, 4. All right, I'm going to cancel this. Damn. That is pretty terrible. I mean, we did handle most of the requests, which is good. But fuck, this is terrible. Instagram. Oh my god. Uh, this is funny though. Now that is one fast request. But come on, this is pretty terrible. And this just blows up every now and then. So my thinking is that we will want to, inside of Riot, right, have some tests for have some tests for um, massive amounts of file descriptors, just to see, you know, we make this change, does that help? Does it not? Because I think what we just did helped in Riot, like from Riot, it helped. I think we're not seeing it hang as often, right? But we're definitely seeing it hang every now and then. My guess is that it is some of these operations that are expensive, like remove by, right? Or find all by, or find by. So those are the ones that will lock and will take the longest, right, to unlock the table. So for example, here, right, you have to sequence the entire table, run a function over them, and then remove the things you don't care. And if this was 100 entries, it would be fine. Like if we go into Atacama, right, I don't expect this to be a problem at all here. Let's just make sure the server is dead, right? Yeah, this has not affected it at all, right? If anything, it looks like the throughput is even higher. Okay, it's going down now. So something happened there. Right. It might be that when we are starting to do the teardown, right, of a connection, and we need to remove some of the file descriptors, right, that we are actually locking a lot. So let's see who the hell is using remove by, right? And here, right? Net.io. This is the timer wheel. It's okay. Like right now, this is not a problem, right? The timer wheel is just a collection of timers, right, that we iterate or tick every scheduler loop to understand, like, what should we send you a message? Should we run a function or something, right? It makes an event loop, really. What are you doing? Mwah. So cute. Look at camera. So cute. All right, so let's go into Net.io. Line 75. When we unregister a process, oh my god, this is the absolute fucking worst. Because this happens all the time, right? And the longer the table of sockets, the longer it will take to remove a process from here. So nope, this is not happening. And this table goes from why are you so wet? What do you do? Have you been leaking yourself? Showering, you say? I don't know if I would call it that, a shower, but okay. Ow. I'm gonna bite you now. You okay? So I think the best thing to do here would be to actually keep reverse lookup table. So we have file descriptors to process, which is fine, because every time we get an FD that we get a file descriptor, right? We want to find the processes that are associated with it, and it's usually one. So we may want to allow for more entries just than one, but let's go with one right now. So if we go into procs, eventually we'll see when we do poll, right? We iterate over the file descriptors to see if we should wait. This is bad. Yeah, so this will go through so many descriptors, right? Before we do a single poll, which would explain the high latency on some of them. Because if we're doing this, or if before we do this, something else locks, right, the table, that we won't be able to get the descriptors in time. Okay, we'll leave this there for a second. Uh, the next thing is that once we got a raw descriptor that's ready for us to operate on, right? We are calling find all, and find all logs the table and filters the entire table, right, by that function. And this is a bad idea. We're filtering all of the file descript. Oh my god, what are we doing here? I am amazed this work. I mean, that it ran past a couple dozen file descriptors. We already know which file descriptor we need to look for. That's fine. So we should just pull that up, like just do a lookup there, right? We got this thing, raw file descriptor, right? So we could do an FD, and that will be FD make raw FD, right? If we really wanted to do that. And then we can do procs, and that will be dash map get, right? And then we'll do tprocs FD. And this thing should give us all of the processes, right, that match that file descriptor. And now this will be a list that it would be okay for us to filter on because it would be so much smaller, right? It most likely will be a single one. So modern flag. So now we can do list filter, right? And we can do procs. The other way around, actually. Procs goes at the end. So we're going to pipe that. What are we listening to? Spotify. All right, people, we've been listening to Foo Fighters for almost 3 hours. Any recommendations? Just drop a link and we'll start there. Spotify link better. Otherwise, I will just pick something from here, like Jacob Collier or Nep. Play. We are on. Thanks, Dylan. Okay, so let's do the interface first, right? We want to get a key VT, and we'll get a K, and then we'll return a list of V. So this is all of the keys that you have there. We actually can even make this easier, because once we have that descriptor, right? Okay, now so we have to go through each one of them, but we don't get a process there. We just get a proc and a mode. Cool, that's the one we want. I will bite you. If you bite me, I will bite you. Get T, and then we have a key, and then we'll just do the same thing we do everywhere, right? And then we'll do hash table, right? And then find all. What are you doing with your paw? No. Find all. This is exactly what we want, right? There you go. What? No, you don't like that? Leia. What's the problem here? Cool. Format, doing test. Is that consistently going to be an error? No. Okay. So far, so good. Cool. So if we go here into Nomad again. All right, 10K is fine. We're still like blocking at the 16K mark. And then nothing happens. Why are we blocking there so much? Okay, we're gonna open instruments now, and we're gonna see where the hell are we spending so much time, because clearly there is somewhere, right? Hello, instruments. Just open yourselves. Instruments. No. Instruments. Steam is not responding. I don't see instruments here. Why don't you want to open? How am I supposed to debug things if I cannot open instruments? Instruments damaged can be opened. I think if we go into privacy and security, no. I don't get it. It is not. It is really not opening at all. Okay. So we removed one iteration process here, right? So that's good. So what happens if I remove all of this find all and remove by? The timer will. Okay, my bad. IO 75. This one's still terrible. Unregistering a process by going through everything. Absolutely ludicrous. Ludicrous. I wonder though, we have a process, right? And the process has ready file descriptors or file descriptors that it's consuming. No, so these will be the ones that are ready, which doesn't necessarily mean that they haven't been readied right for you yet. So what we can do is do an FD stable, right, where we put the file descriptor. So the opposite table, right, and that will be pretty straightforward to do. So then we can do get, right, in FDs, and then we get proc, right, and this will be a list of file descriptors. And then we can do dash map, remove, or yeah, remove. Because for blocking, we probably want to do remove all. So we just, if you give us a list of keys, then we'll remove all of those. Cool. So that makes some sense to me. We definitely want to pass in the table here, and that will be procs. And then we can do dash map, remove. Right? So this is the combination here, right? When you register process, we save in a table from process to file descriptors, right? So that then later, when you unregister yourself, we can quickly use you to find the file descriptor, right? And use that and remove that one, right? From the lists. Cool. So two things we need. We need remove. If you give me a key value T and you give me a key, then I'll give you back a unit. And remove all. Like that. But I think I'm going to need to reintroduce some of the old things we had here in the interface. What? They are here. Cool. So that's that. And now in our tables here, we'll do FDs, and this will be process D, right? And like that. I think we can actually use, god damn it, I can't type anymore. We can use the size here. Cool. So we have that, right? I like that the throughput stay consistent. That's pretty good. Ooh, look at that. 22. Damn. Pretty nice. Some people have pointed out that that particular benchmark is not very interesting. You're just saturating the TCP stack of the operating system. And I'm like, but that's kind of the point, right? Like, I want to make sure that we, Riot, right, can read and write to sockets as fast as the operating system allows us. So now let's try this. So my expectation is that now, if it does hang, you will be at a higher number of sockets, right? Let's see. Yeah, that did not work. Invalid. Oh, sorry. We need to kill the TCP server, right? Same expectations though.